Okay, today's lesson will be called Sine Law. Okay. Does anyone think back to grade 10? When do you use Sine Law? Anyone remember back to grade 10? Sort of. Sort of. There's a special type of triangle though that you use Sine Law for. No, they're totally opposite in fact. Okay. So Sine Law is going to be used when
triangle?
no, well, close. This is used in non-right angle triangles.
So like obtuse?
Sort of. When opposite sides and angles are known. And I'm going to draw a nice triangle like this. Okay, now this equation right here, the thing is, SOHCAHTOA is beautiful. It's a nice thing. What do you need to have happen for SOHCAHTOA? What does it have to have?
An angle on the side.
Yeah, good. Something else though. That is true. You do need that. Okay. There's one other thing SOHCAHTOA. You have to only special type of triangles use SOHCAHTOA. 90-degree angles. Good. So this can be used even if the angles here are not 90 degrees. Okay. And which most triangles in the world aren't actually like that. Okay. So my equation, I'll give you guys a second to scribble this down. My equation I'm going to do, and this should look familiar to some people, is sine A over A equals sine B over B equals sine C over C, or A over sine A equals B over sine B equals C over sine C. I'll get out of the way here. Okay, so this is just good algebra here again. This is meant to be fairly nice for you guys here. I don't need to work out there before we start here. Okay, because in this whole trig unit, I strongly recommend bringing a calculator every day. We'll be using calculators all the time in this unit. This is very calculator heavy. Okay. Now you may say, oh yeah, Mr. Sadler, it's two equations to have to know. All right, how's the first and the second equation related?
The exact same thing.
Just flip. Like there's a numerator and denominator just flipped. Okay, so it's okay for that. Why do you need two versions of the same equations? I don't remember from last year. I know two of you I tutored last year, so you should hopefully remember this from that.
So one for angles and one for sides.
Yeah, exactly. Okay, so what I do, and I'm going to do this on the next few examples, I'm always going to put the unknown at the top left. It's easier to solve that way. Okay, so that's why the two versions of the equation. Okay, here we go. Example 1. Says, solve for x to one decimal place. Okay, by the way, as I'm doing these, if you haven't seen this before and I'm going too quickly, please somebody stop me and ask questions. Okay, I get going too quickly and sorry with this. I've been sort of going fast and been mean to people in this class in the last week, and I'm sorry about that. So if I'm going too quickly, I forget that math isn't everyone's best subject in the world, right? So if you need me to do an example again or talk with again, let me know. Please, I'm here to help you guys remember that, okay? Example 1 says, solve for x round to one decimal place. Okay, and please, and I told you guys this at the beginning. We're going to tell you one last time. My triangles are awful, okay? And that is not a 65-degree angle. It's nowhere close. That is not a 52-degree angle. That's nowhere close. That's not necessarily. It looks like to me like an equilateral, right? Like all sides being the same, but it's not. Please go by the numbers that are on there rather than my silly drawings. All right, so can someone who was in grade 10 get me, sorry, someone who was in academic class should get me started on this. Matt, go ahead.
Could you start by labeling your triangle?
Yeah, if you want to. I know Mr. Stratton teaches, he does this sort of thing, right, where he does like this and this. So that means there's a cross, so it's, I don't know how it works exactly, but you use Sine Law for that. If you want to do that, Colin, you want to try? Yeah, right, well, we don't really need to find another angle though. We'll start with this.
Please excuse me for the interruption. At this time, I would like to ask all Chippewas of Nawash and Fucking First Nation students to go to the cafeteria for a post-secondary presentation. That will take at least for the remainder of the period. Thank you.
Okay, so I'm going to say put the unknown at the top left. Okay. Now, here's the thing that has to get people. So the x is my unknown, that's what I'm looking for. What angle is related to x? 52, okay? Now remember, we're looking for angles that are across from each other, so x relates to 52. Always with an angle, you do sine or cos. We're just going to say sine 52. All right. Now, what's the other information going to be? What's the other, what else is, what's the second, the right-hand side equation going to be now? Yeah, go ahead.
9/765.
Yeah, and the way, very good, Nick. Now, the way you remember this is, again, like sides go with sides in the numerator, like sides go with sides and angles go with angles, right? So if you have a side here, there has to be a side here. If you have an angle there, there has to be an angle there, all right? And unknown goes to the top, so we're solving that. Now, how do we get x by itself? We have one last step to get x by itself. It's x divided by sine 52. How do you get rid of the sine 52? Okay. Oh, yeah.
How do we know there was sine and not like
Oh, because for this one here, the only reason you'd use cos or tan would be if it was a right angle triangle. Okay, so if this, since there's no right angle triangle here, you have to use a different type of equation to solve it. All right, so for us right now, we're going to know it's sine law because we know opposites. We'll talk on Monday about a third option there when you don't have them. Okay, so basically my rules are for math is if it's a right angle, use SOHCAHTOA. Then try and use sine law because it's easier, and then go to cosine law if you have to. That's sort of how it works here. All right, so that's x divided by sine 52. How do you isolate x? Thank you. Okay, we're going to multiply by sine 52. So we're going to say x equals 9 times sine 52 divided by sine 65. Okay, Conrad, I'm going to pick on you. Can you please use the power of the calculator? Calculate that for the class, please. And we said round to one decimal. 7.8 is what I got as well. Okay, so everyone take a second in their calculator to make sure they can get that answer. Okay, because it's one thing for Conrad and I to have the right answer, which is good that he and I both did. Okay, right, but we need to make sure that everyone's got that. If you're not able to get that question. No, just for me, like dot means multiply, that's why. So I always will. As well, I'd recommend always putting the number first. If you do sine 52 times 9, they may think like the angle times by 52, which it's not. Right, it's just going to be the length. Anyone unable to get that? Take a second, try, please.
I got 7.1.
Uh-oh.
I don't know why we're here.
Uh-oh. 9 times. Oh, okay. You did, that's the numerator, so go to divide by 65 sine. Was the account?
Yeah, for today.
Okay, everyone else good? Yes, Will, all's well? Okay, let's try example 2. I want you guys to try this before me. It's the very same with different numbers. Example 2 is going to say, solve for x down to one decimal place. That's crazy. Okay, so there's going to be my second triangle here. It's going to be that one. Okay, so I'm going to hit pause the video and give you guys a chance to try that out. All right, and then we'll, if you need a hand getting it set up.
If you get some,